Once again, good morning, everyone. In continuation of last week, we know we are completed, I think, 4 experiments. One is single linked list, double linked list, circular linked list, and stack implementation using an array. Is it clear? I think most of the people are even executed and they are updated in the record and observation also. Is it right?
Yes, sir.
Yes, sir.
Yeah. Today we are going to discuss about queue implementation using an array and linked list representations. Already we know, but even though we can understand again with the programmatic way, already we discussed about the program instructions. Still, we are going to discuss here how the queue is implemented using array and linked list. This is the fifth experiment. Here, I think you are all of you aware of that because queue data structure already you people are already done in your first mode examination also. Most of the people are maybe written, some are not. I don't know. But even though again we are covering the things. Now tell me, any one of you, what is a queue data structure? What are the properties of queue data structure? Anyone? Hello? For any one of you, please explain what is a queue data structure and its properties. Don't waste your time. Quickly.
So queue is an abstract data type, sir. Similar like stack.
Okay. That's enough.
Queue is a linear data
It is
structure
open at both
in
the
which
things, sir.
insertion operation and deletion operation are performed at two different ends.
Yeah. Continue, Anusha.
Uh, Insertion is done at rear and deletion is done at the front of the queue.
Okay.
Insertion is also called as Enqueue and deletion is also called as Dequeue.
Okay. Enough.
It also follows first in first out principle or else last in last out principle.
Yeah, right. Very good. Here, Q is a linear data structure, and the queue is having two ends. One end we are going to use for insertion, that is called as Enqueue from rear. That is end is called as rear back end, and we can delete the element from front side of the queue to another end. Here it is the operation is called as Dequeue. That front is called as front only. Now this queue always follows first in, first out or last in, last out principle. So these are the properties. If you know, then the implementation of this queue using array and linked list also very easy because we know the array and you know the linked list. So that easily we can implement our queue with help of array and queue, array and linked list. Okay. Now just I am going to share my board. Is it visible? My board is visible, everyone? Hello?
Yes, sir. Now it is good. Yes, sir.
Yeah, yeah. Now, as per the discussion, we know the queue is, today we are going to discuss about queue ADT, ADT means abstract data type. Now, queue is, both sides are open. Here one side is used for inserting the element that is called as Enqueue. Here another size we are using to delete the element. It is called as Dequeue. So this inserting end is called as rare. So this deleting Dequeue end is called as front. Two pointers are required. One is front, another one is rear. Here both are pointing to different ends. So this always whatever the elements you are inserting, for example, 17, 18, 19, 20. Here now if we want to insert, here 17 will be inserted here, and 18, and 19, and 20. When you want to delete, whatever the order you are inserted, in the same order it is going to delete. That's why it is going to follow first in, first out, or last in, last out principle. Clear everyone? Queue data structure now? All of you clear? Hello?
Yes, sir. Clear.
Yeah. Now you can implement this queue two ways. The experiment also having two sections. One is using array, another one is the using linked list. So using pointer dimension, pointer is nothing but linked list. Don't confuse. Okay, already I told you. Now using array. Now first of all we are going to understand using array how to implement the queue. Now I think everyone knows array is having static nature, so that when we are going to use array, you must be defining the size of the array. Here, when you are defining the size, we cannot increase the number of element you want to insert. It is not possible. That size is fixed. That's why it is having static nature. So that this queue is called as static queue also. Here, that is why I have to declare first array size. Maybe if you take the array name is QE or Q, whatever it is. If you take 4, then the queue size must be 4 only. Yes or no? Yes or no? Hello?
Yes, sir.
Yeah.
Yes, sir.
Because the array size is declared only 4. 0, 1, 2, 3. Here, before that, one more point we need to understand. Here, this queue also having two errors. What are those two errors? Tell me. Like stack, here also two errors are there. What are those errors? What are those errors? Hello? Queue also having two errors. What are the errors are there? Is it audible? My voice is audible?
Yes, sir.
Yeah, I am asking what are the errors are there for queue? Like stack, you also having two errors. What are those? Oh, you people have forgot. Tell me what are the errors are there in stack?
Stack
Overflow and
overflow and stack
underflow.
underflow.
Like queue also having. What are the errors? Same errors.
Same errors.
Queue,
Q underflow, Q overflow.
overflow error, and queue, underflow error. Here, when the overflow error will come? Tell me. When the overflow will come?
When the
If
number
the
of
queue is
elements
full,
exceed the
Yeah.
yeah.
The size of the queue is full. Even though we are trying to enqueue new element, maybe there is a problem. We cannot insert any element because the size is already full of queue. Yeah, such error is called as overflow error. Then underflow. What is underflow?
if the queue is empty, even though we try to delete the
Hmm.
elements.
Yes, underflow will come. So this is what two errors. Same like stack. Here also we have two errors in a queue. Okay, right. Now we are discussing implementation of queue using array. Now this is array. I have taken array size is 4 so that my queue size also 4. Now I want to perform operations on queue. Now tell me, first of all, I'm going to insert element in queue. The insertion of element into queue is called enqueue. Now tell me when I cannot insert element into the queue.
When queue
You
is
know
full.
that the initially front and rear must be points to -1 because we are using array implementation, right? Right. Okay. Now tell me when we cannot insert element into the queue. Someone is given the information. The queue is full. Now, how I know the queue is full? How I know the queue is full?
If rare is equals to max minus 1.
Yeah. Here, if you take the rear equal max -1, here I have taken n, then the condition is logic is how we have to write if rear because we have to insert from rear only. Here, if rear is pointing to 3 means n minus 1, then rear equal to n minus 1, then there is a chance of queue is full. If the queue is full, we cannot insert. Here you can type that is a overflow error. Yes or no? Yes or no?
Yes,
Yes,
sir.
sir.
Right. Here else, here remaining all the cases, here except the queue is full, remaining all the cases, we can insert the element. For example, front and rear is pointing to 1. Now you want to insert some elements. Yes, you can insert. Now front will be incremented by 1 and rear will be incremented by 1. This is front and this is rear. Even one more element you are going to insert. Yes, your rear is not n minus 1. Then we can insert one more element from the rear. Are you following? Even you want to insert one more element. Yes, you can insert element from the rear. If you want to insert one more element, yes, we can insert from the rear. Rear will be incremented by 1. Yes, there is no effect of front. And now if you observe like this, now elements we are inserting. When again you want to insert one more element, now rear is pointing to n minus 1, so that we cannot insert element into the queue. Yes or no? Now queue is overflow. Yes or no?
Yes, sir.
Yeah. Yeah, same for the same, the logic, the code is, already. Here, initially we need to define the size of the queue because the size, and the front is pointing to minus and rear also pointing to -1 because it is empty. Uh, coming to insertion, here I have taken the name is add, otherwise you can take any Enqueue also, whatever the name you want. Here already I told you initially if the queue is empty, here how we know the queue is empty? It is pointing to -1. Here both are pointing to -1. That's why queue is empty. Right. Now I want to insert element. I need to check the queue is overflow or not. So for that the condition if rear equal to max minus 1. Already I told you, you know very well. Then printf queue is full. Else means we are going to insert the element in a queue. So for that we need to check queue is empty or queue is having some space. If the queue is empty, front equal to -1, so that we are going to increase front equal to 0. Otherwise, directly rear will be incremented by 1 and we are going to insert element into the rear position. So this is what exactly the Enqueue insertion operation. Is it clear? This code is clear?
Yes, sir. Clear.
Yeah. Now coming to Dequeue. Means we are going to delete the element. Always we are going to delete the element from the front only. Here when, first of all, we need to check when we cannot delete the element. Tell me when we cannot delete the element?
When queue is empty.
Yeah, when queue is empty. Here, how we know the queue is empty?
If the front node is equal to -1.
Yeah, front equal to -1. If this condition is satisfied, queue is empty, means underflow. If the queue is empty, we cannot delete any element. Here coming to else. Here else means here maybe the queue is not empty. Queue is having some elements. Here, how many elements are there? It is immaterial. The simple logic is we need to check the elements are there or not. If the element is there, we can delete. Here, the delete option is not possible in this array implementation. Just front will be moving. So for example, front is pointing to this 0 indexing, rear is pointing to 3 indexing. Then what happened here? If you want to delete front, then front will be incremented by what? Simple, like this. The front will be moved like this. The front will be moved. Now, even though front is having element, here when you want to delete this, the front is moving to out of the rear. Means front is always less than the rear. But when the condition is fails, then what happened? The queue is going to becomes empty. That's why in this case, if front is greater than rear, otherwise front is less than rear only. If the front is becoming greater than of rear, then front and rear pointing to minus. The meaning is we are deleting the queue is having only one element, so that element also we are going to delete. That's why front and rear is pointing to -1. Is this clear? The logic is clear? Is this logic is clear? Because it is array implementation.
Yes, sir.
Yeah. Sure, for that, the code is very simple. Already we know if the queue is empty, you cannot delete any element. If it is underflow, that is the condition is front equal to -1. Else means the queue is having some elements. Here, yes, if the queue is having elements, you can delete directly front plus front. Yes, we are moving. But even though after moving, you need to check if front, already I told you, front is greater than or not. If the front is greater than or rare, compulsory, here that is having only one element here, so that we are deleted this, so that front and rear pointing to -1. Otherwise, in remaining all the cases, if this condition won't work false, then it moves to here out of this condition, here like this. So this is a simple code, very there is no complexity, very simple code. Are you understood this code? Is it clear this code?
Yes, sir.
Yeah. Now coming to the display operation. Here display of the queue. Here when you want to display elements in the queue, now tell me. Here always the queue contains elements. How we know how many elements the queue contains? How to calculate how many elements are there in the queue? Hello? For example, my front is here, my rear is here. Now tell me what is the queue size? What is the queue size?
4.
My front is pointing to 1 and rear is pointing to this 3. Then what is the queue size?
2.
2 only. Always the queue will be start from front and ends with rear. Don't calculate array size. Here already I told you, here we are implementing queue. So that here always the queue start from front and ends with the rear. Here front to rear only we need to calculate. We need to understand these are the elements are available in the queue. Is it clear?
Okay, sir.
So that just we don't need to check from 0. Just we have to check the elements which are from front to rear. That we are going to display. That is enough. No need to check the array index. Are you clear?
Okay,
Are you
sir.
clear? Yeah. Now we are moving from front to rear. We have to start from front. Instead of moving front pointer, you take one temporary pointer. Then you take it. First of all, we need to check the queue is empty or not. If the queue is empty, we cannot display any element. That's why if front equal to -1, or you can take rear equal to -1, then queue is empty. We cannot display any element because it is empty. Else only the point we have to remember. Here the thing is, Here we have to take one temporary variable, temp equal to front. With the temp, we have to move. Here we have to write uh, temp. Temp is less than or equal to rare. T is less than or equal to rare. You need to try. You need to display one by one element. Okay, how we are going to display? Here Q of T, then T plus plus. Here like that, we have to increment and we are going to display the element. Here for that, I am going to show. Are you clear? The logic is clear?
Yes, sir.
Logic, yeah. Here I have taken for loop and I. Here front equal to equal minus 1, Q is empty. Then else, here I am going to print the elements. Here instead of temporary variable, I have taken here I. Whatever variable you can take it. Instead of writing for loop, you can write while loop also, not a problem. But here I have taken while for loop. Even you can use while loop also. For I equal to front, meaning temporary variable, the front is assigned with the temporary variable. And already I told you I is less than or equal to rare. Then I plus plus. Here like that, every element we are going to print from front to rare. So this is the logic actually. So that is only the queue. So don't think about I equal to 0, then I will start with array. Here array is not a matter. Here we are implementing queue data structure using array. That's why you need to consider front to rare. Now clear this code?
Yes, sir. Clear.
Yeah.
So
Yeah.
someone's waiting outside.
Someone waiting outside. Yeah. Okay. One guy is waiting. Okay. Anyway, still people are joining means only half an hour is there. Why they are joining late? Okay. Now I'm going to run this code. Yeah. Now I want to display the elements using option 3. Now you know the queue is empty. Okay. That's why I want to delete with help of 2 options. Again, queue is empty. Then I will go with one option. Here, enter the element. Just I entered element 23 is inserted. I want to display. Yes, 23 is there. Again, I want to insert element. Here there is no option. Compulsory, we need to insert element from the rare only. Here, then rare means this 56 will come after 23. Then I will go with the display. Yes, it is working. Again, I want to add one more element. Is it clear? Yes or no? It is working.
Yes, sir.
Now I want to delete. Here it won't ask anything. It is going to delete from front only. Yes. Which element? 23 is deleted. Means first element it is displaying. Yes. Again, I want to delete. Yes, it is going to display. Yeah. Only one element is there. Again, I want to delete. Yes, it is deleted. When I wanted to display the queue, then it will show empty because all elements I deleted. Yes or no? Now it is working. Is it clear?
Yes, sir.
Yeah. Please try to execute and understand the program and try to execute and update your observational record. Is it okay? Is it okay? Now the queue implementation using linker list. Here you know the linker list is having dynamic nature, correct? Whenever the memory is required, we are going to allot the memory dynamically so that we are not worrying about the size of the uh, memory and we are not worrying about before implementation. We no need to define the size. Whenever we need, we are going to allot the memory so that there is no chance of the overflow error. Yes or no?
Yes, sir.
Yeah. So for the single linked list, we know we have the node structure. Your node is divided into how many parts? Then we need to define the structure. Node is divided into how many parts?
2 parts.
Huh?
2 parts.
2 parts.
2 parts. Here one part is for storing the data. Another part is storing the address of next connected node. Yes or no? Yes or no?
Yes, sir.
Here the code is like this. Here this is a node. You know very well. Here start to node. Here a data part, and it is storing the address. Here initially the front and rear must be points to null because the queue is empty. Correct? Is it right?
Yes, sir.
Right. Now coming to the operations. Now we know initially the queue is empty. The front and rear points to null. So that queue is empty. Now I want to insert element. If I want to insert element, I'm going to call a new node and allot the memory dynamically. Yes or no? And add the data and add the next part is null. Correct?
Yes, sir.
So that your new node is ready. Now you want to insert this new node in a queue. Here, first of all, we need to check the condition. What is the condition we need to check? So there is no chance of overflow error in this linked list implementation. Yes or no? It is a dynamic. So that we need to check queue is empty or not. Yes or no?
Yes, sir.
Hello? Yeah. Now what is the condition we need to take? If the queue is empty or not?
If front equal to null or rear equal to null.
Yeah, front equal to null. If the front equal to null, the queue is empty. If the queue is empty, then your new node is going to become as a first node. Yes or no? Yes or no?
Yes,
This
sir.
is your new node. Here it is going to become as a first node. This is a front and this is a rear. Are you clear?
Yes, sir.
Are you clear? Yeah. Else means the queue is not empty. Queue is having some elements, maybe one element or more than one element. Means queue is not empty. Means how we know the front or rear not pointing to null. So that queue is not empty. Then your new node is ready. Then you need to insert. Here how to insert? Here we know the rear also. From rear only we have to insert. Here this is a new node. We are inserting. Here this is a new node. We are inserting after the rear. You know the from rear. Then you know the rear. Here rear next equal to nn and rear equal to nn. Rear next equal to nn. Here rear next connected to nn. Then rear equal to nn. Like that, if any node you want to insert again, your new node will come here. Means how to insert? Rear next equal to this is it, right? This is rear. Rear next equal to nn and rear equal to nn. Yes or no? Like that, you can insert n number of nodes whenever you want to insert. Is it clear?
Yes, sir. Clear.
Yeah. Yeah. Now coming to the code, same thing here. Here you need to call the node. Here I have taken new node name, and instead of edit, I have taken directly the name is new node, and the dynamic memory allocation is done. You know how to allot the memory dynamically. Already we know. So many times we practiced on that, and we have to allot the value for this new node data, and new node next is null. Already we know. Now already I told you just now, here we need to check the queue is empty or not. If the queue is empty, front equal to null. If it is like that, then your new node becomes as a first node. That's why front equal rear equal to new node. Otherwise, else, here already we know rear next equal to new node, rear equal to new node. Is this clear? The code is clear, everyone?
Yes, sir. Clear.
Yeah. Now coming to Dequeue, means deletion. Here, when you want to perform deletion operation on a queue, here, first of all, we need to check when we cannot when we cannot delete element from the queue. Tell me, when we cannot delete element from the queue?
And queue is empty.
Yeah, when the queue is empty, that is a underflow condition. Underflow condition is possible in the queue implementation using linked list. Now tell me here what condition we have to verify. What is the condition? What is the condition? Hello? How to know the queue is empty?
Front equal to null.
Yeah, front equal null or rear equal null. Yes, the queue is empty. If the queue is empty, we cannot delete any element because no element is available. Yes or no? Yes or no?
Yes, sir.
Yeah. Now, else. Else means queue is not empty. Queue is not empty means queue is having, again, we need to check two conditions. Queue is having single element or more than one element. If the queue is having, for example, queue is having only one element, means like this, front is pointing to same element and rear also pointing to same element. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Yeah. So that's why if both are pointing to same element, means front equal rear. Both are pointing to same element, we need to delete anyway. Here from front only. But after deletion of this element, here front and rear points to null only. Here that's why here two conditions we need to check. If the queue is not empty, queue is having single element or queue is having more than one element. First of all, we need to check if the queue is having single element, means if front equal rear, then we are going to delete this element. How to delete? Just we have to write, you take temporary variable t equal to front and front equal to rear equal to null, then free of t. Then it is going to delete and front or rear points to null only. Yes or no? Yes or no?
Yes, sir.
Else. Else means queue is having more than one element, means like this. If the queue is having more than one element, very simple. We need to take temporary variable. Here t will be assigned here. Now t equal front. Your front is moved to front next. Your front will move to front next. Now we can free of t. So like this, we can delete a number of elements. Understand? Logic
Yes.
is clear? Yeah. Now coming to the code. Here already we know. Here, if front equal to null, then queue is empty. We cannot delete any element else. Here, else means here front is not empty. It is having some elements. If it is having some elements, then we are going to delete. Yeah. So already just now we know one temporary variable we need to use and which is assigned to the front. Now using this front equal to front next. The front is moved to its next. Then here, the data we are going to display and free of temp. Now it is going to delete the element. Is it clear?
Yes, sir.
Yeah. Now coming to the last operation, display. Here already we know always the queue is going to represent from front to rear. Yes or no?
Yes, sir.
Yeah. Now initially we need to check queue is empty or not. How to know the queue is empty? If the queue is empty, we cannot display element. So that if front equal to null, then there is no element in the queue. Else there is an element. If there is an element, then you can take one temporary variable assigned to temp, and we need to print the data of the each node until it moves to the rear. So that is here t is not equal to rear, then you need to print t data. Here, then t moves to its next. Like that, it is going to traverse until end of the queue. So this is what exactly the display. So the code is very simple. If front equal null, your queue is empty, we cannot display any element. Else, here already I told you, we need to define one temporary variable which is assigned to the front of the queue. Now, temp next is not equal to null. Here, last node, the pointing to null only. Always this is going to null. Here, until that, we have to move. So that here, temp next is not equal to null, then we have to traverse. temp data, temp moves to next, temp data, temp moves to next, temp, until temp next is moves to null. Once it is moving, it is going to stop. Then it is going to print the data, whatever the elements are available in this particular queue. Is it clear? The code is clear, everyone? Hello? The code
Yes,
is
sir.
clear. Yeah. If it is clear, then I will run this code. Yeah. Now coming to enter your choice, again I am going to display. Now queue is empty. Then I want to delete with help of second option. Again it is showing queue is empty because it is empty. Now compulsory I need to insert using with one. Yes, I inserted 23. Again I insert 45. Now I want to display. Yes, 23 is there, 45. Again I want to insert one more element. Uh, 89. Yes, it is inserted. It is inserted from where only. Correct? Yes or no? Again, I insert one more element. All these elements are inserting from where only. Yes or no?
Yes, sir.
Now I want to delete. Here, when it is going to delete, automatically it is going to delete from front only. Means 23 has to delete. Yes, 23 is deleted. Front is deleted. Again, you want to delete. Then you can use delete option. Again, it will be deleted from front only. Again, deleted. So only one element. Again, I want to delete. Yes, queue is empty. Again, I want to delete. Queue is empty. It will show. So this is the what the program is. Is it clear, everyone? Is it clear?
Yes, sir. Clear.
Yes, sir.
Now you know these are the two programs under fifth experiment. Here, maybe everyone is understood this particular queue implementation using array linked list. Correct?
Yes, sir.
Yeah. Please try to practice these two programs and execute in your machine and update in the observation. If it is good, then you can update in the record also. Yeah, by the next week, you must be update and forward to my official mail ID. Okay, is it clear? Still any doubts or anything is there regarding your laboratory? Because 5 experiments are done. We have only 4 experiments. Total 9 experiments are there. Out of 4, already we know 2 experiments. One is sorting, insertion sort, bubble sort, and selection sort. Already we discussed all these sorting techniques. One is searching, linear search, binary search, very simple programs. Means we have only 2 experiments. Okay, because these two also already we know in a searching linear search, binary search techniques in your first year, even though I will explain, but just I'm telling that's what most of the 80% of the laboratory syllabus is over. That is why any doubts are there in this up to now. Any doubts are there on this laboratory syllabus? Hello?
No, sir.
No. Okay, good. Still, you practice this. Anything is there, you do that. And already I told you, insertion, bubble, and selection sorts already done. Here, if the time permits, you try to execute those programs also, because our time will be saved. Okay, we will go for another program. That's why please try to practice already the notes and everything I shared. Please try to practice those programs. Okay, is it okay?
Okay.
Yeah, practice it. If it is done, then you update in the observation record